The story of the universe's origin has long fascinated humanity, from ancient myths to the latest scientific theories. One of the most widely accepted scientific explanations is the Big Bang theory, which suggests that everything we know emerged from an extremely hot, dense point known as a singularity. This idea has been central to our understanding of cosmology for decades, but in recent years, new discoveries and alternative theories have challenged this narrative. Could it be that the universe didn't begin with the Big Bang? Could it have existed before, perhaps cycling through phases of expansion and contraction? In this extended exploration, we'll dive deep into the intricacies of the Big Bang theory, its inflationary model, and the challenges it faces from competing theories. We'll also consider the broader implications for our understanding of time, space, and the very fabric of reality. The classic Big Bang narrative. Most people are familiar with the traditional Big Bang narrative. It describes how the universe began approximately 13.8 billion years ago from an infinitely small, infinitely dense point called a singularity. This singularity is thought to have contained all the mass and energy that make up our universe today, compacted into a space with zero volume. For reasons still not entirely understood, this singularity exploded in what we now call the Big Bang, expanding rapidly and creating all the matter, energy, and space that exist today. In the first tiny fraction of a second after the Big Bang, the universe underwent an extraordinary process known as inflation. Between 10 to the power of negative 36 seconds and 10 to the power of negative 32 seconds, the universe expanded exponentially, growing much larger in size than it had been in the moments before. Following this period of inflation, the universe continued to expand, though at a much slower rate. Over time, matter began to cool, and particles formed, eventually coalescing into the galaxies, stars, and planets that populate the cosmos. The universe continues to expand today, with galaxies moving further apart as time goes on. If the universe didn't begin with the Big Bang, then what was the Big Bang? Some physicists suggest that it wasn't the beginning of time and space, but rather a transition phase in the universe's evolution. According to the inflationary model, the Big Bang was the moment when inflation ended and the universe entered a hot, dense state. But inflation itself may have been preceded by other events, possibly extending infinitely into the past. Another possibility is that the Big Bang was just one event in a much larger multiverse. In this view, our universe is just one of many, each with its own set of physical laws and constants. The multiverse theory is supported by some interpretations of quantum mechanics and string theory, which suggest that different regions of space could have different properties. If this is the case, the Big Bang may have been the beginning of our observable universe, but not the ultimate origin of everything. The future of the universe. The question of the universe's origin is deeply intertwined with its ultimate fate. If the universe began with a Big Bang, will it end in a big crunch, where everything collapses back into a singularity? Or will it continue to expand forever, eventually reaching a cold, empty state known as the heat death? Alternatively, if the universe is cyclical, as in the Big Bounce model, it could collapse and bounce back into a new phase of expansion. Current observations suggest that the universe is expanding at an accelerating rate, driven by a mysterious force known as dark energy. If this acceleration continues, the universe will likely experience a big freeze, where galaxies move so far apart that stars burn out, and all matter decays into low-energy particles. In this scenario, the universe would become a dark, empty expanse. However, if dark energy is not constant but changes over time, the universe could eventually stop expanding and begin contracting. This could lead to a big crunch, followed by another big bounce. Some physicists even speculate that the universe could experience an infinite series of bounces, with no true beginning or end. Conclusion: the search for a deeper understanding. The origin and evolution of the universe remain some of the most intriguing and challenging questions in science. While the Big Bang theory has provided a robust framework for understanding the early universe, it is increasingly clear that this model may not tell the whole story. Alternative theories, such as the Big Bounce, suggest that the universe may have a far more complex history than we previously thought, with no true beginning or end. At the same time, new observations from telescopes like the James Webb Space Telescope and studies of the cosmic microwave background are forcing scientists to reconsider long-held assumptions about the universe's evolution. As we continue to gather more data and develop new theories, our understanding of the cosmos will undoubtedly evolve, potentially leading to even more profound insights into the nature of reality itself. In the end, whether the universe began with a bang, a bounce, or something entirely different, the quest to understand its origins and fate will continue to captivate scientists and laypeople alike. As we explore the mysteries of the cosmos, we may find that the answers to these fundamental questions lie not just in the distant past, but in the future as well. One alternative theory is the Big Bounce model. According to this theory, the universe didn't begin with a singularity but instead emerged from a prior phase of contraction. In other words, before the universe was expanding, it was contracting. At some point, this contraction reversed into expansion, not as a violent explosion, as in the Big Bang, but as a smooth transition known as a bounce. The Big Bounce model suggests that the universe could undergo an infinite series of expansions and contractions. Each cycle would begin with a bounce, followed by expansion, and then contraction, leading to another bounce. In this model, the universe has no true beginning or end. It stretches infinitely into the past and future. Physicists who support this theory argue that it resolves some of the problems associated with the Big Bang theory. For example, the Big Bounce avoids the singularity issue, as the universe never reaches infinite density or temperature. Instead, there is a minimum size and energy density, which prevents the breakdown of physical laws. Moreover, the Big Bounce model can explain the observed homogeneity of the universe without requiring a period of inflation. Challenges to the Big Bang from observations. In addition to theoretical challenges, recent observations have also raised questions about the validity of the Big Bang theory. The James Webb Space Telescope